Hey kiddos, here's a review for trig, chain, and implicit differentiation. Okay, first off I've got tangent of 2x squared, and I see that I've got some kind of a function on the outside, inside, and then super inside. So to take the derivative, I'm going to think about this as secant squared of tangent of 2x squared times the derivative of the inside, which is secant squared of 2x squared times the derivative of the super inside. That's definitely the formal name for it, which is going to be 4x. Which secant squared, that looks good, looks good, looks good, looks good. B. I'm not even going to look at these as far as the things that are going on here. Okay, so we've got sine of tangent of 4x squared. We've got inside and inside here. So that's going to be cosine of tangent of 4x squared times the derivative of tangent, which is secant squared of 4x squared times the derivative of 4x squared, which is going to be 8x. Should also be an extra parentheses there, and we are good. For number 3, we've got cosine of 4x to the 5th. That's going to be negative sine of 4x to the 5th multiplied by 20x to the 4th. For number 4, here we got a product rule, things being multiplied together, and we also have a chain within the first part of the product. Okay, so we've got the second, 2x cubed plus 5 times the derivative of the first, so secant squared of 4x squared, and then the chain times 8x, and that's going to be plus the first tangent of 4x squared times the derivative of the second, which is going to be a 6x squared. Okay. Beautiful. Number 5. We've got another product rule going on. So we've got the second. It's going to be 3x to the 3rd plus 4 times the derivative of the first, secant squared of x to the 4th. And then we've got a chain going on times 4x to the 3rd. And then we're going to add the first. So that's going to be tangent of x to the 4th times the derivative of the second, 9x squared. Beautiful. For number 6, we got a quotient rule going on, so that's going to be the bottom. Cosine of 2x to the 3rd times the derivative of the top, cosine of 2x to the 5th times 10x to the 4th, that's a chain rule, minus the top, sine of 2x to the 5th times the derivative of the bottom, negative sine of 2x to the 3rd times 6x squared, and that's all over the bottom squared, so cosine squared of 2x to the 3rd. Fun. First page done. Next we've got secant of 3x to the 3rd. Derivative of secant is secant tangent. So we're going to have secant of secant 3x to the 3rd tangent of secant of 3x to the third. That's my first layer. That's times the derivative of secant of 3x to the third, which is secant of 3x to the third times tangent of 3x to the third times the derivative of 3x to the third, which is going to be 9x squared. Thank you, Mr. Butterworth, for that delightful problem. It's all his fault, don't worry. Alright, we've got a power rule with stuff on the inside, so that's going to be 4x to the fourth plus 5 to the third times the derivative of the inside, which is 4x to the third. For number 9, we've also got a power rule. That's going to be 1/3. Negative 3x to the fourth plus 1 to the negative 2/3. And then times the inside, which is going to be negative 12x to the third. For number 10, bring the 4 down. 4 times x plus 1 to the third. The derivative of the inside would be times 1. For number 11, we've got a product rule with some chain rule stuff going on as well. So that's going to be negative 3x to the fifth minus 2 to the fifth times the root of the first, which is going to be negative 3x squared. And then we're going to have plus the first, negative x cubed plus 4. And that's times the derivative of the second, which is going to be 5, negative 3x to the fifth minus 2 to the fourth times the derivative of the inside, which is going to be minus 15 x to the fourth. All right, that's everything on page 2. Page 3. We've got a quotient rule going on here. Make a really, really long line, and the bottom is going to be 5x to the fourth plus 2 squared. So we got the bottom, 5x to the fourth plus 2 times the derivative of the top, which is 3x to the fifth minus 1 to the third, and then times the derivative of the inside of that, which is 15x to the fourth, minus the top, 3x to the fifth minus 1 to the fourth, times the derivative of the bottom, which is going to be 20x to the third. For number 13, we've got to use implicit differentiation to get y prime by itself eventually. The big rule of thumb is anytime we take a derivative that involves another letter than x, we have to have that as the derivative as well, using the chain rule. So, for number 13, we've got 9x squared plus 12y squared, and here we have to have that dy dx, or y prime, and that's going to be equal to the derivative of 2 is 0. Getting the dy dx by itself, we're going to minus x squared to the other side and divide by 12y squared. And when we do that, it's going to be minus 9x squared over 12y squared, which is negative 3 over 4 x squared over y squared. All right, for number 14, which is going to be really similar, we've got 15x squared minus 9y squared dy dx is equal to 0. This is going to end up being 15x squared over 9y squared is equal to dy dx after you move things to the other side and do some dividing. For number 15, we're going to have negative 10y dy dx. Again, every time we do a y, we have to have a dy dx. Minus 15y squared dy dx plus 0 is equal to 2. We're going to factor out dy dx, and that leaves us with negative 10y minus 15y squared. And then when we divide by that, we get 2 over negative 10y minus 15y squared. For number 16, I have a really similar process. That's going to be negative 15y squared dy dx minus 4y dy dx plus 0 is equal to 6x, and that's it. Factor out dy dx. So we got negative 15y squared minus 4y. That's equal to 6x. Divide, and we end up with 6x over negative 15y squared minus 4y. All right, that'll do it for page 3. All right, here we end up at about the level that you're going to see because we have some product rule stuff happening here. And that's a pretty easy way for us to kind of check out what's going on. So let's do the dy dx stuff first. We're going to have negative 10y dy dx. And then we're going to have a product rule here. So that's going to be the second y cubed times the derivative of the first, 3x squared. I'm going to keep the minus because that makes that a little trickier. First, x cubed times the derivative of the second. That's going to be 3y squared dy dx. We have to use that implicit part there also. And that's equal to 15x squared. I'm going to combine like terms for everything with the dy dx to the left side, everything without it to the right side. And I'm also going to factor out dy dx in this step. So that'd be minus 10y and minus x cubed times 3y squared. On the other side, we got 15x squared. I'm going to move this guy over, so that'd be plus y cubed 3x squared. And then I divide. So dy dx is equal to 15x squared plus y cubed times 3x squared divided by negative 10y minus x cubed times 3y squared. And now we've got to plug in the point negative 1, negative 1. dy dx at x equals negative 1, y equals negative 1. And that's going to be equal to 15 plus negative 1 times 3. And the bottom is going to be 10 minus negative 1 times 3. So that's plus plus. So the top would end up being 12, the bottom is 13. All right, for 18, basically the same thing here. We've got two different product rules. So we're going to have a product rule going on there and there, which is going to be delightful. I could do some algebraic manipulation to make that less awful. But that might be too scary, so let's just kind of go at this as if we were just doing the derivative and moving forward. Okay, so we've got the second y cubed times the derivative of the first, negative 3x squared, plus the first, negative x cubed times the derivative of the second, 3y squared dy dx, and then plus 0 is equal to 3x squared, and then plus, we've got another product rule here, the second y cubed times 6x, and then we've got 3x squared times 3y squared dy dx. I'm going to bring all the dy dx's to one side, the left, and move everything else to the right side. I'm also going to factor out a dy dx at this point, and that would end up giving us negative x cubed 3y squared. That's from this one. And moving this one over, that would make that minus y. Oop, that's just this part. So minus 3x squared times 3y squared. The other side of this, we're going to have negative 3y cubed x squared, but on the right side that becomes positive, and then plus 3x squared, and then plus 6xy cubed. When we go to divide this, we got dy dx is equal to 3y cubed x squared plus 3x squared plus 6xy cubed, all divided by negative 3x cubed y squared minus 3x, sorry, let's make this minus 9 by multiplying the two 3's, x squared y squared. And we're plugging in the 0.11, so we get 3 plus 3 plus 6 over negative 3 minus 9, which is going to be 12 over negative 12, which is negative 1. And I guess that's it. The rest of these are the answers.